Okay, what we're going to cover now is we're going to cover p-values. And p-values stands for probability values. It's a number that's calculated from a statistical test. And what it does is it describes how likely you are to have found a particular set of observations if the null hypothesis is true. So that's the technical definition, but for a data analyst or a data scientist, really what that means is if you have two columns of data, at least two columns of data, is there a relationship between those two columns of data? Is there an insight that we can pull between those two columns of data? When you talk about p-values, p-values are often used in terms with hypothesis testing. And with hypothesis testing, what we're doing is we're trying to decide whether to reject the hypothesis that there is no relationship between two columns of data. The smaller the p-value, the more likely you are to reject the hypothesis that there is no relationship between two features or two columns of data. So one of the questions I ask in the slide is, what is the null hypothesis? All statistical tests, they have a null hypothesis. And for most tests, the null hypothesis is that there is no relationship between your features, or the two features, or however many features you're comparing in your data set. There's all kinds of tests, right? One of them is called a two-tailed T. T is in Tom, t-test. And so the null hypothesis is that the difference between two variables or two groups is 0. So to give you an example, for instance, you might want to know whether there's a difference in lifespan between two groups of mice that are fed different diets, diet A and diet B. You can almost envision two columns of data, one representing diet A and one representing diet B. The null hypothesis is that there's no relationship. There's no relationship between the diet and longevity. The p-test will tell us whether there is a statistically significant relationship between those two. So if I look at what exactly is a p-value, the p-value, it tells you how often you would expect to see a test statistic as extreme or more extreme than the one calculated by your statistics test if the null hypothesis of that test were true. So the p-value would get smaller as the test statistic that's calculated from your data gets further away from the range of the test statistics as predicted by the assumption or the hypothesis that two columns of data have no relationship. So the p-value is a proportion. If your p-value is 0.05, that means that 5% of the time you would see a test statistic at least as extreme as the one you found if the two columns of data had no relationship. None at all. This is all about statistical significance. P-values are often used by data analysts and data scientists to say whether a certain pattern in the data that they've measured is statistically significant. This statistical significance, this is the gold standard for identifying new knowledge, for claims. If you claim that there's a relationship between two features or two columns of data, then the way that you prove that is to back that up with these statistical tests. So that is what the p-values are. That's what the p-values are all about. But that is, frankly, that's a bunch of words. That's a bunch of words. So what I want to do is I want to just give you the bottom line. This is the bottom line of what you need to know as a data analyst or a data scientist about p-values. The p-values will tell you if there is a statistically significant relationship between two features in your data set. So that means that the p-values are, frankly, they are critical when you're doing a bivariate analysis. A bivariate analysis. The magic threshold is 5%. It's 5%. So that's the threshold, and so we say if the p-value that you have, if it's greater than 5%, then what we're saying is that there's no difference between your two columns of data, or at least two columns of data. There's nothing statistically significant about those two columns of data. There is no relationship between those columns of data. It's just like if you found footprints in the sand, and the two columns that you had to evaluate that were eye color and weight. You would see no statistically significant relationship between eye color and weight with respect to the footprints found on the beach or at the beach. If p, however, is less than 5, then that means that there is a statistically significant difference between your two columns of data. Imagine, one column that is indicating whether you're a smoker and another for insurance rate or quality of water and longevity. The p-value, it's saying that if we have that set as 0.05, it's saying when I would expect to find that same level of detail at 5% if there were no relationship between the columns of data. Okay, so the threshold is going to depend on your field of study. Sometimes people say 5%, sometimes people say 1%, but 5% is usually the standard. So the bottom line up front is that find the values of p, the probability values. And with that, you can find deep insights in your data set. So that should be a part of your bivariate analysis. There's different tests that help you find these p-values.